In this tutorial, we will learn how to use RapidMiner to build a prediction model using multiple linear regression when some of the independent variables are nominal. The assumption is that you're familiar with the conceptual foundations of regression, so our emphasis will be on how to use the software to build the model, train it, and validate it with validation data, and then looking at its performance. So we will estimate model parameters using training data, and then the coefficients and diagnostics that are generated as part of the training process. We will take a look at those and interpret what they are saying. And then we will take the trained model and evaluate its performance using validation data and a collection of performance metrics. So the data set that we are going to use for this model building exercise is a used car data set from India, and we have extracted 7 variables, 5 of which are quantitative: the mileage of the car in kilometers, efficiency in kilometers per liter, engine capacity in cubic centimeters, power in brake horsepower, and the price in local currency appropriately scaled. The 2 nominal or qualitative variables that we have also included amongst our independent variables are fuel type. You can see some of the fuel types there. It's compressed natural gas, petrol, diesel, and liquefied petroleum gas. And the transmission can be manual or automatic. So the prediction model that we are trying to estimate is the second equation that you see. So we are trying to predict price as a function of all those independent variables. So essentially, we are trying to compute the coefficients B0, B1, B2, B3, and so forth. Now, the coefficients for the 2 qualitative variables, fuel and transmission, I've drawn in a different color solely to draw your attention to the fact that these 2 variables are different from the quantitative variables, and they have to be treated somewhat differently in the model building process. And we will see what that is as we begin that journey. So let me start up RapidMiner and commence with our model building process. So there is our standard RapidMiner user interface. Now the steps, some of the steps that you will be seeing here are identical to the steps that we did with multiple regression when all the independent variables are quantitative. So I will go through those steps somewhat quickly, but I will focus my attention on the newer steps, the steps that are distinctive to dealing with the 2 qualitative variables. I will devote more time to those. So the first step is to retrieve the raw data itself. So the raw data file is this one which says qualitative 3. So I will just highlight that data set and drag it in to the process box, and that will bring in the retrieve operator that will actually get the raw data for me. Now the first thing I want to do now is tell RapidMiner that out of all the variables, those 7 variables in the data set, price will be my dependent variable. So for that, I pick up the set role operator. I drag the set role operator into the process box. I connect the first operator to the second by connecting the output port of one to the input port of the second one. And now I highlight set role and I move over to the parameter panel. And there I tell RapidMiner that out of all those 7 attributes, I hit this drop down button and I identify price and say that it's going to be a label. That's the term that RapidMiner uses to identify a dependent variable. So far, everything, the 2 steps have been identical to what we did for multiple regression when all the independent variables were quantitative. Now comes the difference. I need to tell RapidMiner that I have 2 qualitative variables that I need to code. Now, I had set up an earlier tutorial for you called data preparation, in which I give a lot of the conceptual details, conceptual foundations, and further details of encoding qualitative variables, nominal variables using dummy variables. So I will refer you back to that video in case you have forgotten its contents or you want to see further details. But essentially, we have to take these 2 qualitative variables and code them using dummy variables, which are 0-1 variables. So the operator to do that conversion, this is something new here that we haven't done for the previous multiple regression. So we pick up the operator which converts in nominal to numerical. That's the operator. So you can see over here, here's the operator that we're looking for, nominal to numerical. And I pull that over into the process box, and I connect the previous operator to nominal to numerical. And now I highlight this particular operator, nominal to numerical, and I move over to parameters, the parameter panel, to customize it. Which parameters, which variables do I want to code, and so forth. So first thing is, I tell RapidMiner is I want to pick out which attributes I want to convert. So I tell RapidMiner, hey, there's a subset of attributes. I know there are 2 attributes. There's a subset that I want to code. I want to convert from qualitative to numerical. So then I say select attributes, and you can see automatically RapidMiner is smart enough to know that out of all those attributes that you have, only 2 are qualitative, and it only shows you those 2. Those are the only 2 that are subject to coding, okay, being coded from qualitative to numerical. So I highlight fuel, I move it over to the selected attribute list, and I pick the transmission type, I move it over to the selected attribute list. Hit apply. So I have selected my attributes for conversion. Now at this point, let me temporarily just connect this output port of the nominal to numerical operator and connect it to results, just so that we can see what has happened so far as a result of the conversion. So I run this process, and you can see that RapidMiner has converted the fuel type and the transmission type from names like compressed natural gas, liquefied natural gas, to 0,1 variable. That's what is dummy variable coding, right? So I just wanted to show you what the results. But one thing you have noticed, the names of these variables, it says fuel equals petrol, fuel equals diesel. So what that, if you wanted to interpret what that means, is for the first car, so row number 1, fuel equals compressed natural gas is 1, all the other ones are 0. So this car had compressed natural gas. Similarly, car number 3, its fuel was petrol. So that's the interpretation of the 0,1 variables. Now, the norm for naming these variables is that you use an underscore. So let's get back to the design. And I scroll down in the parameter panel, and I tell RapidMiner, please use underscore in the names of the converted variables rather than the equal to sign. And notice that the default is that coding type that RapidMiner uses is dummy coding, the 0,1 coding. Again, please refer to the prior tutorial that I had on data preparation for some of the conceptual details behind it. Okay, so let me delete this link because I had created it just to show you temporarily what the output would be. And now you also know that due to multicollinearity, one of the dummy variables needs to be deleted. So let me make some space over here for myself. So out of all the dummy variables that have been created, one of the dummy variables for each qualitative variables, one of the dummy variables needs to be dropped. So I need to do that by using the operator called select attributes. So I pick this operator, put in here, and what I'm about to tell RapidMiner now is out of the new dummy variables that have been created for each qualitative variables, namely for fuel type and for transmission type, delete one of the dummy variables that was created, and this is due to multicollinearity. Again, please refer to the prior video on data preparation for conceptual details on that. So let me connect the output port of this conversion operator, nominal to numerical, to select attributes. And now I highlight select attributes, that operator, and I'm about to tell RapidMiner which dummy variable to drop. Okay. So again, I want to select a subset to be dropped. In particular, I want to drop one dummy variable for each qualitative variable. So I click on the select attributes button, And now I'm about to tell RapidMiner which dummy variables to drop. Now, just for a couple of minutes, let's see what RapidMiner has created. Do you see that for the qualitative variable fuel, it has created 4 different dummy variables, one for each type of fuel that's there in the data set. So there are 4 types of fuel in the data set. So for each type of fuel, it has created a 0, 1 variable. Okay. Similarly, if you look at transmission, the qualitative variable transmission can take on only 2 values, automatic and manual, and RapidMiner has created 2 dummy variables, one for each value of that qualitative variable. Now, the one that I want to drop, I want to drop liquid petroleum gas. For among these 4 dummy variables that were created for fuel, I want to drop LPG because it has the fewest number of records in the dataset corresponding to liquid petroleum gas. Similarly, this being India, most of the cars are manual transmission. There are relatively few automatic transmissions. So in the dataset, there will be relatively much fewer records corresponding to automatic. So I want to drop automatic. So among the dummy variables, I want to drop transmission equal to automatic. And for fuel, I want to drop fuel is LPG. So let me highlight these 2. So what I could have done is I could have selected all these other variables, and it's kind of painful to do that. So instead, here's what I'm going to do. I'm going to select liquid petroleum gas as the type of fuel, and I'm going to select automatic as the transmission type, as if I'm selecting just those 2, when in fact I want to do just the reverse, opposite complement of that. So I selected those 2 attributes, and now I tell RapidMiner, please invert my selection. So this is a sort of a little bit of a roundabout way of telling RapidMiner, please select all attributes except those 2 that I highlighted. Okay. So these 2 steps that I have just shown you, that is nominal to numerical conversion, and then dropping one of the dummy variables for each qualitative variable, that those are the 2 steps that are distinctive to handling the qualitative variable. So now the remainder of it will be very similar to what we did when all the independent variables were quantitative. So we will go through them somewhat quickly. So the next step is I will split this data set into a training and validation data set. And for that, I use the split data operator. So I bring that up here. I connect the previous operator to it. I highlight split data, and I go over to the parameter box and tell RapidMiner, I click on add entry. I tell RapidMiner that the first partition should have 70% of the records. I add another entry where I tell RapidMiner that the second partition should consist of 30% of the records. Okay, so I've split the data. And the sampling type I will pick as shuffle sampling, so that those 2 subsets are created by randomly selecting records from the data set. So now that I have split the data, I have set things up now that I'm able to feed into my the star of the show, which is the linear regression model. So here's the linear regression operator. So I pull it in, and I feed in the first partition from the split to linear regression in order to train it. Okay. As soon as I do that, you can see that RapidMiner has made the second partition available to me that I will use later on for evaluation. So let me move this over to the top. It just visually might be easier to watch. So now that I have trained my linear regression model, I'm going to evaluate its performance by making some predictions and comparing it to actual data. So to make my predictions, I use the apply model operator. Here's my apply model operator. I drag it into the dialog, the process box. It needs 2 inputs. So this step is exactly the same as what we did for when the independent variables were quantitative. So I feed in the trained model, and let me move it over a little bit, and I feed in the validation data set. here. So that's the second partition from the split data. So I feed in that validation data set, and the apply model operator will generate the predicted values. Okay, so let me move in a little bit here. Now I can do my performance evaluation, which I do using the performance operator. See, here's performance. And I pick up the performance operators that is specific to regression. This is the performance regression operator. So I pull it in to the process box, and I feed it the predicted values and the actual values. So from the validation data set, I have generated predicted values and I've got the actual values, and I feed that into the performance metric, the performance operator rather. I highlight the performance operator and identify which metrics that I want. So as you saw with the previous multiple regression video, I picked the root mean squared error, I picked the absolute error, and I pick up the correlation and the squared correlation as the R squared. Now I just remembered something, that when I created the linear regression operator, I remember I emphasized when we were doing the regression for the quantitative independent variables that when we set up the linear regression operator, I would like to instruct RapidMiner not to do any kind of thinking on my behalf. So I want to specify to RapidMiner that it should not select any independent variables on its own. So this feature selection should be set to none, and this eliminate collinear features should be unchecked. Okay, so the full output should be generated by RapidMiner. It should not do any thinking on my behalf. Okay, so now I am almost done. So the performance metrics, the output port of performance, I connect to the results port so that I can see the output, and I connect the examples port to the results port also, because I want to see the actual and predicted values, and I want to see the model itself. I want to see the coefficients, so I connect the model to the to a results port. So now the process has been set up. Again, remember, just me point out the major components of this process. This is the star of the show, the linear regression operator. And remember, when setting it up, let me highlight it once again. When I set it up, this box over here, where it's the feature selection box, should be set to none, so that RapidMiner does not do any thinking and simplification of the model on its own. Okay. Now, everything around this linear regression operator to set it up. So these two operators, the nominal to numerical and the select attribute, these two operators were needed to first code the qualitative variable as 0, 1 dummy variables, and then to drop one of the dummy variables to avoid multicollinearity. So those are the two new operators in this process, when we're modeling using some nominal independent variables. So the apply model, the performance operator are exactly the same as before, as what we had when all the independent variables were quantitative. So these are the major components of the process: the linear regression model, the conversion of the qualitative to the quantitative variables, the training, and the performance measurements. Okay, so now we are ready to run the model. Let's run the model here. So I click on this arrow button, and there you have the model generated for you. You can see the model coefficients here. Those are your B0, B1, and so forth. So you can see that after having dropped one of the dummy variables, we now have 3 dummy variables remaining for the fuel. Okay, and we have 1 dummy variable remaining for transmission type. Okay, so I will not repeat in great detail, what these t statistics and the p-values mean. So these p-values are used to test the hypothesis that the true coefficients are different from 0. Remember, these coefficients that you get in the coefficient column are from the sample. They're simply proxies for the true coefficient, and we are always at the back of our mind worried that the true coefficient might be 0. So this p-value gives you an indication of whether or not the true coefficient is different from 0. And essentially, you're looking for p-values that are lower than a certain threshold. The common threshold is 0.05, but you might also use a threshold of 0.01. Now, the performance vector, the performance metrics, just as we saw in the case of the all quantitative independent variables, we have the root mean squared. Here's the correlation. Now, if you look at the video for the all quantitative case, you will find that the R squared, or the squared correlation value, is slightly lower than this 0.588 that you're seeing. So adding the fuel type and the transmission type appears to have improved the fit just a little bit, but not by a whole lot. You can go back and look at that video and see the numerics. Okay, so essentially this model building a prediction model using linear regression, multiple linear regression, when some of the variables are nominal, is very much the same as what you do when building a prediction model using linear regression when all the independent variables are quantitative. The major difference is that you got to take the qualitative variables and code them using dummy variable. This is that nominal to numerical step. And then, because of multicollinearity, you need to drop one of the dummy variables. So for each qualitative variable, you take all the dummy variables generated from it and you drop one. Okay, the rest of the process is very similar between the case where all the independent variables are quantitative and where some of the independent variables are qualitative. So this is the overall model building process. Thank you for listening, and thank you for your attention.